Yeah, so as Adam mentioned, my name's Peter. I'm the co-founder and CTO of Private AI. As you might imagine, we're a privacy company. Despite coming from Australia, we're based up here in Toronto. We're a Series A startup focusing on privacy tech, primarily around unstructured data and text, and also generative AI. So today my talk will be two parts. First, I just want to talk a little bit about some things to be aware of with privacy and LLM applications, and then I'm going to pull the cover back a bit on our system, talk a little bit about how we serve our models. Yeah, great. So let's get started, and let me just start my timer. So how long this takes? Great. So, as I imagine many of you noticed, OpenAI was in the news a lot earlier this year for data privacy concerns. March 21st, they had the first data leak, which exposed a bunch of user chat histories, which included credit card information. 10 days later, they got banned in Italy by the Italian Data Protection Authority, which was pretty big news at the time because the GDPR regulators usually don't move very quickly, and it's very rare they take the step of actually banning something. Italy banned it, and then a number of other countries, such as Canada and also Germany, launched investigations. But it was only banned in Italy. And a few days later, the French digital minister was also in the news for saying it didn't respect privacy laws, and it nearly got banned. But as we now know, that didn't actually happen. So what was the concern? Like, why is it so bad on privacy, and why did it get banned? Well, it all stems from the fact that LLMs are very, very good at remembering stuff, particularly around the training data. And OpenAI at the time didn't have great data privacy controls. So there was a ChatGPT interface. You could type it, ask questions, and basically all of that information they were saving and using, at least they retained the right to use that to improve their models. And yeah, it's been shown that it's very easy to extract information from generative models once they've been trained. So this is a piece of research a few years ago done on GPT-2, but basically you can see that just by prompting the model, you get it to spit out a whole bunch of sensitive information. It's not in my deck, but most recently, OpenAI launched the GPTs feature, and already within a week, people had figured out how to get them to regurgitate the training information, which in some cases was like CVs and sensitive information, stuff like that. This is an example of it going wrong in practice. This is from a few years ago. This South Korean company called Scatterlab. It was a dating platform, and they had about 10 billion conversation logs of just like it's a dating app, so very intimate information. They trained a chatbot on this data and then put that into production. And once that happened, like without anyone like exploiting the model, this is not a hack or something. It just started spewing out like really sensitive information to different people, and that got pretty high up in the news. Now, fast forward to today, like OpenAI is no longer much in the news about data privacy. The concerns that were raised earlier this year have largely been resolved. Italy, of course, lifted the ban. France didn't ban it, neither did Canada or Germany, so it's gone better. There's also now the Azure OpenAI service, so you can use OpenAI's models, but with all the data security and enterprise-friendly stuff that Azure offers, which, yeah, like for a lot of people, ticks the boxes. But it's interesting that even today, this is a study from August 23rd, the number one reason enterprises are not adopting LLMs is still data privacy, and just they've got a whole bunch of sensitive stuff and they don't want to be sharing that outside of their organization. So despite it not being in the news, it's still pretty high up on people's minds, at least in the enterprise. So that's the problem. The particular approach that we take is data anonymization and also synthetic data generation. So we find all the sensitive bits of information like names, phone numbers, email addresses, but also just anything that could be sensitive, like if a company's about to perform an M&A, and removing all that stuff so that the model, like all of that really sensitive stuff is never shared with the LLM you're dealing with. And here's an example of how our system works. Like it deploys via an on-premise container. So we're not, at least until now, we haven't been a cloud service. And we pull all the PI out before it leaves customer premises. It goes to the LLM, gets processed, and then the response is put back together. And yeah, just a few key features of the platform. We do a whole bunch of different languages and entities. And interestingly, stripping out PI also helps reduce bias in the outputs you'll get from ChatGPT. So removing PI can also really help with compliance in that regard. Great. So that's part one of my talk, like basically what we do and setting the scene for just a few things to keep in mind with data privacy. I guess one note on that is just, yeah, like using things like GPT-4 at inference time, yeah, the privacy concerns around that have largely disappeared. But when you're fine-tuning models, this is really where it's still as important as ever, that if you're fine-tuning GPT-4 or, sorry, that's not yet available, but like GPT 3.5 or doing anything like that, you really need to be cautious of what's going into these models. For us, as you can imagine, we use an NER style system, although with a lot of modifications to make it work better, which are largely encoder style models such as BERT and Roberta. And we deploy on premise so that, and we have a number of unique requirements, which I thought was just worth talking about today. Just how we do that. So when I talk about serving, like as Adam mentioned, MLOps is and like inference serving. I mean, I've been doing this for a long time, but it's always been a very niche field until about the last year with the advent of these massive models, which you really kind of have to do something to get them to run at any kind of reasonable speed. But even then today, MLOps resources are very hard to find. I still hear stories of people spending millions of dollars a year, even just serving like BERT and Roberta style models. And I think there's just a big gap in the industry right now that there's still not a lot of benchmarks comparing all the different serving libraries, and there's very few user experiences to learn from. So from this particular section, I just wanted to talk a little bit about what we do, what we found to be good, and what I would suggest are the production ready things that you should be using. And I'll also back this up with hard benchmarks, which can lead to a 10x cloud bill reduction. At least it has in our case. So just to talk a bit about the requirements of us and deployment, we have a number of requirements. So because we're not a cloud service, like it's not like we just deploy once and then serve a whole bunch of different customers. We deploy where our customers are, which means it needs to deploy everywhere. That could be a Windows server in a data center somewhere. It could be AWS in the cloud. It could be even on someone's laptop for testing. So it needs to run everywhere. It needs to be really reliable, and it needs to be easy to deploy. And then we're also do a lot with structured data and just large use cases where you could be dealing with terabytes of information. So being able to process all of that cost efficiently as well. To this end, we've got two different flavors of our system. We've got a CPU build, which just walks, quacks, talks like any other Docker container that we can give to a DevOps person, and they'll be able to go run with it for easy deployment, runs on any x86 CPU. And then we have a GPU build, which uses NVIDIA GPUs. And that's really for like those large customers with terabyte scale requirements. Like say some of the Macs, for example, that we work with. As you can imagine, like many others, we develop our models in PyTorch. So step one is getting them out of PyTorch. And the best way to do that is with the Open Neural Network Exchange, or ONNX. And it's a nice platform-independent format for neural networks. And it's a bit like TensorFlow 1 in that it's graph-based, so it allows for model optimization. So you can do all kinds of like things like operation fusing and replacement and stuff like that. And it's got great support these days in PyTorch and Hugging Face. It's still a de facto way of exporting models from both Hugging Face and PyTorch. Although I guess some of the newer tools like TensorRT LLM, which I guess I'm not talking about today, that converts directly from PyTorch model. But in the case of BERT and Roberta style models, it can be even as simple as a one-line command when it works, which these days is most of the time. Once it's in Onyx, that then opens up a number of different options you can use for serving. We investigated 3 different libraries for serving these models, and without question, Onyx Runtime, which is developed by Microsoft, was the best solution. It was the most performant by virtue of having the most transformer-specific operations, such as fuse, multi-head attention, all that kind of stuff. It's very reliable. It's used in a lot of different places, and it's quite easy to use. So it's a high level of maturity, especially today, and it's very performant. We also had a look at TensorFlow Lite, but that's primarily meant for computer vision, so it didn't really feature any transformer optimizations. And it's also meant for edge devices. You can still run it on x86, such as Intel and AMD CPUs, but that's not really what it's built for. And we also tried Intel's OpenVINO package, but at least when we tried it, it really wasn't production ready. I had to modify a few things in the source code to get the models to convert properly. And it has improved a bit since then, but it's still Intel only. So why wouldn't you use the platform that supports any x86 CPU? And GPUs as well, like I'll come to. The integration's great with Hugging Face, and just a quick call out as well, it actually offers very good quantization support. So what that means is if you use 8-bit dynamic integer quantization, like what you would normally do on CPU, you actually lose less accuracy with Onyx Runtime than with PyTorch. So that was quite an interesting thing we found. So yeah, bottom line with our question, Onyx Runtime. And it's really easy to use as well. Like you can see here, it's 6 lines of code to get it to run. And that's basically our CPU build. So we just use Onyx Runtime with models converted from PyTorch. And yeah, I really can't speak enough to how great this library is. On CPU, it's only 4.5 megabytes. So it makes for, like, we deal with a lot of financial institutions and banks. So we always get put through the ringer with security scans. There's very little dependencies. So like security scans, handing it over to a DevOps team is just really simple and easy. And it just deploys and runs everywhere. And it's also worth calling out that CPUs don't require batching to get good performance. So there's really very little to it in terms of getting this to run fast. And just to note that, benchmark-wise, so this is from an internal benchmark we did, just switching to Onyx Runtime is a bit over 3 times as fast. So it really makes a difference. For GPUs, though, which you would need for the big applications, we had a look for that as well, and we really boiled it down to 2 different options. There's NVIDIA's Trident, which I think people are maybe, although it's been around since 2018, I think people are maybe a little bit more aware of it today, and TorchServe, which was developed by Amazon. And yeah, again, without question, Trident was by far the best. It was about 4 times as fast. And it just used a fraction of the memory, the GPU memory as well, as what TorchServe did, which, yeah, especially with LLMs today, is everything. And Trident, you don't really hear a lot about it. I'm talking about NVIDIA Trident, not the OpenAI Trident, which is the language integrated with PyTorch. All the big tech companies use it. I believe even, I don't have a source for this, but from what I understand, OpenAI also use this to serve their models. So it's really reliable, although it looks pretty scary, unlike any other NVIDIA product. I find the documentation isn't great, but it's actually quite easy to use when it comes down to it. And honorable mention to BenchML and Selden. Selden in particular is like an end-to-end MLOps platform, but yeah, given the experience we have with Trident, we didn't really look around. And yeah, Trident's been around again since 2018, so it's 5 years old now, which is forever in machine learning land. So it's quite a reliable product. It's worth calling out though, it's just a model serving engine. So basically it's responsible for running the model and batching the requests together, but the actual inference backend is selectable. So you can use PyTorch, TensorFlow, Onyx Runtime, which is what we decided. And they also recently launched support for TensorRT LLM, which is what it used to be called Faster Transformer, but yeah, now with LLMs, that's of course been rebadged. So you've got a bunch of different inference backends that you can use, which is great. And putting it all together, this is what the benchmarks look like. So you can see that switching just from like a simple fast API plus PyTorch Docker container to Trident plus Onyx runtime, it's 11.5 times faster. So it really does matter, and you can get some massive speed improvements. And what this means now is terabyte scale data processing at a reasonable cost. So with GPU, we can process a terabyte for less than $1,000, which, yeah, that's a great outcome. That makes it feasible. 11 times that's $7,000 per terabyte. That really would eat into the margins of our product. It's also worth noting, though, that CPUs aren't actually as bad as what they're typically made out to be. Although you can see the throughput is a fraction of what a GPU instance provides. When you consider cost, it's actually about a 7 times difference. So yes, that's a sizable difference, but it's not that 20 or 100 times that people will typically think between CPUs and GPUs. And of course, spot CPU instances are a lot more available than GPU instances, so that would bring that differential even closer. And putting it all together, this is basically what our deployment process looks like. So we develop in PyTorch, we convert the models to Onyx, we apply different quantization, so 8-bit dynamic for CPU and 16-bit floating point for GPU, and then we serve them with Onyx runtime and Trident for GPU. And that's my talk. So just in summary, it's 2023, and the Onyx ecosystem these days is really, really great as opposed to what it was a few years ago. And transformer model optimization really matters. I guess I haven't talked about LLMs specifically, but I can tell you based on the internal tests that we've been running, libraries like VLLM and especially TensorRT offer at least this kind of performance improvement. So there it's really a must. Onyx runtime isn't great for LLM, so I'm only going to put it forward for BERT and Roberta encoder style models, but for that, it really is great. But NVIDIA Trident with all the different backends, if you're really serious about serving LLMs, nothing's going to beat NVIDIA Trident plus TensorRT LLM. The proof's in the pudding. Companies like Mistral, that's all what they're using to serve their models. And that's my talk. Thank you.